Okay, so good morning, everyone. Let's make a start with respect to this a lecture. I'm sharing my screen. So again, good morning, everyone. So let's see where we are with respect to this module. You recall last week we discussed about we are discussing a chapter on IoT protocols in general. Okay, so we had initial discussion of different types of IoT protocols that we have, a unique characteristic of IoT systems or sensor systems, why traditional protocols used on in a wireless network, in Wi-Fi and everything cannot be used in our case. So we have seen it is constraints environment, low power, a low bandwidth, and a large number of transmission that should happen. Small transmission, but a large number of transmissions. So for all these reasons, the previous protocols cannot be used. This is why we have specific protocols for a IoT, for sensor systems. And we are currently discussing mainly messaging protocols. And one of the most popular messaging protocol is MQTT. We have discussed MQTT in detail. We have discussed MQTT implementation as well. Now we are moving on to a next protocol, which is called the COAP. Okay, that is Constraint Application Protocol. So another messaging protocol, quite popular. So I have chosen those two. There is a third one coming next week. So hopefully we'll complete this one this week. So basically, it is another messaging protocol, but you will see how it is different from MQTT. And why do we have COAP? In which cases COAP can be interesting, COAP can be very useful. So these are questions we'll try to address. And also, just like we have discussed for MQTT, that is how COAP works, how the message exchange happen, and what are the different steps, what is the format of the packet. So all these questions we'll try to address in this lecture for today. So actually we can say that COAP is an alternative to MQTT. It is another messaging protocol which can be used as an alternative in specific cases. So what are those specific cases? This is as we proceed, we'll discuss about it. So let's make a start. Okay, so COAP, as after you, Constraint Application Protocol, is a specialized web transfer protocol. Already, there is something which seems to be new here. Is a specialized web transfer protocol for use with constraints nodes and constraints network in the Internet of Things. So already from the first bullet point itself, anyone can tell me what is new here, what is different from MQTT? Anyone in the class? It is still a messaging protocol, but I want to know what is, already I see something different from MQTT. Anyone? Are you hearing me? I'm not confirmed at the start of the lecture. My slide is visible and you're all hearing me?
Yes.
Yes.
Okay. So it seems that if you're not answering, so you're able to hear me. If you're not answering, you're not getting the point. From this first bullet point here, my question is, what is maybe considered as different as compared to MQTT? Anyone? Adele Oz is around?
Yes.
What do you think?
Constraint networks.
No, but MQTT also was meant for constraint networks. You recall at the start of the MQTT discussion, we had a discussion on why MQTT, how it is appropriate for IoT, and then we said there that low bandwidth, low memory, low computing resources and anything, So MQTT also was for this type of network only. Any other student? Subhachi? Yes, Irfan Subhachi, any idea? If we remove constraints, node constraints network, there is nothing there's not much that remain. I think you should already see where is the difference. Anyone in the class?
Web transfer protocol.
Yeah, this is what remains. Because at the start there is COAP. Afterwards, there is only constraint networks. It cannot be IoT because we are discussing since the start of this module. We are discussing IoT, so it cannot be IoT. So obviously, it should be web transfer protocol. So the idea here, why I have done this small exercise here to tell to try to pinpoint what is different from a MQTT, because this is the main departure, main use of COAP is this web transfer protocol. MQTT, even if it was connecting to a broker, and all communication was happening through the broker. The broker is a specialized like server type system, okay, and your devices connect to the broker. Okay, it was different. Here we are talking about web transfer. Where have you heard web transfer in your? Can anyone give me a web transfer protocol that you are aware? You have studied web, so you know web more than I do.
HTTP.
Obviously, HTTP. Okay, so when we are talking about MQTT, there was no mention about HTTP or whatever. It was MQTT itself. So it was not a web protocol. MQTT was not a web protocol, even if it allowed you to connect to a broker, which is online. This is something else. However, it was not a web protocol as such. Whereas COAP, this is the main thing about COAP. COAP is a specialized web transfer protocol. That is, just like we have HTTP, SMTP, FTP, all these are web protocols that we use over the web. Now you have another one that is called COAP that can be used over the web. However, we already had this discussion. We already have had this discussion. Why? You recall even from first semester, even in second semester at the start, we had this discussion why IoT networks, okay, sensor systems, they cannot connect directly to the web, that is to internet. Let me have, since we have discussed it a number of times, let me see a few words from you. Why? What is a problem there? Why sensor networks, IoT, cannot connect directly like this to the internet as we know it, the web? What is the issue? There are different issues, but tell me what is the most important one. I think I should have a list of names. Otherwise, I will only pinpoint to a few. Bhavish Mohabir, what do you think? My question is, why IoT systems cannot connect seamlessly to internet, that is web? What is the problem? I've tried to address this question a number of times. Is Bhavish around? Okay, so what do you think? Okay, let's try Davison, Pemal.
Yes,
What do you think?
because things are not IP enabled.
True, yes. Can be accepted, yes, true. The network that we are talking about, IoT network, is not IP enabled, true. One of the main reasons why, you recall I've been saying to you so many times, at the lower level layer, okay, that is, it is not 800.11, it is not 800.3 Ethernet, Wi-Fi, it is not those things. What it is, 800.15.4, for example, okay, which is meant for PAN, that is, it is a PAN standard, basically personal area network, and this has not been made to be IP enabled. Okay, so it is not IP enabled, it is not TCP IP enabled for this simple reason. Okay, for this simple reason. I see Ramjani has left. Okay, we'll check it out. Muswafar Ramjani, I see it on attendance. If he has left, we'll remove from the attendance. I don't know whether it's a connection problem, but anyway, I do get message when you enter and when you leave, so I'll take care about it. Yes, let's get back to this question. There are so many reasons, but the main reason your friend mentioned that the network is not IP enabled, because this is why we had to implement 6 low wireless PAN that do the translation from 800.15.4 to web to IP. Okay. That we commonly use over the internet. This is the main reason. Okay, so basically our network normally cannot be connected to the internet because it is not IP enabled. Now we are saying that there is a protocol that is a special protocol meant for IoT system that is called COAP, Constrained Application Protocol, that is a specialized web transfer protocol that most probably it will allow us to communicate our data over the internet, over an IP network. We are going to see as we proceed. So the protocol is designed for machine-to-machine application, such as smart energy and building automation. So originally for machine-to-machine, okay, it is a lightweight M2M, as we call it, machine-to-machine protocol from IETF. Okay, it supports request response. You're familiar with request response because when you have studied your web module or your I don't know, HTTP or whatever, the HTTP and thing, they are request response type of a protocol. Okay, there is also a variation of publish subscribe in COAP. So it can work as request response. Request response. So internet, when you develop web application, you request a particular resource to a server, you get it immediately. So this is called request response. Now there is something called request observe, which is some kind of publish subscribe. Publish subscribe, we have studied it. We have already studied publish subscribe because MQTT was publish subscribe. So basically, you know very well publish subscribe. You show interest to a topic. When a publisher publishes data for that particular topic, the broker returns to you the result. This is publish subscribe. Here, there is a slight difference. There is something called request observe. You request data for a particular value for a particular topic. If you put it, we don't call it topic in COAP. This is why I'm not comfortable in using the word topic here. But let's say since you're already aware of topic, you request for a particular topic, but let's say there's no data for it. That is, it will continue to observe whether we get data for this particular topic, and whenever we have data, it will send it to you. This is the observe meaning. What is this observe? It will observe that particular topic for you because you have requested that particular topic. So some kind of publish subscribe research. So main purpose is what of this protocol is to interoperate with HTTP and RESTful web through simple proxies. So REST protocol, you know, REST model. You have studied REST. You should have. If you have covered any web module, you will have REST. Yes. Anyone have you just informed me? HTTP definitely REST model.
Yes, we have done it in Web 2.
In Web 2. Okay. So you have get, put, delete. These are the common methods that you have in REST. So basically, we'll be using those even in COAP. Okay, so interpolate with HTTP and REST as well. We are going to see how COAP do this. So the goal to enable web services, web-based services in constrained wireless network. Basically, in simple terms, allow IoT to connect to the web, allow IoT to send messages over the web. Okay, and we're talking about constrained wireless network, 8-bit microcontrollers, limited memory, low power. Again and again, we are saying that these are the characteristics of IoT of sensor systems. So problem, why we cannot use HTTP? Web solution are hardly applicable, okay? Because HTTP, TCP, IP, TCP itself is a heavy protocol. It requires lots of congestion management. It requires lots of acknowledgements and everything. So error checking and everything, and it cannot work on those limited memory, limited power a network. We know this. I have been saying this so many times. This is why in this module you are having to study again other types of protocols to do things that you were already doing over the web, like HTTP, REST, and everything. You were already doing it, but it is not directly transferable to IoT. This is why you're having to study other protocol. So solution is what? Redesign web-based services for constrained network. That is what COAP provide. So basically in COAP, so REST model for small devices will be there. Okay, like HTTP, COAP is based on widely successful REST model. Servers make resources available under a URL. Okay, so if there is a particular URL, you type this URL, you request that particular URL to a server, and then it returns to you the information that was there in this URL. So basically, this is how your web works. Okay, and client access these resources using methods such as get, put, post, delete. This is what we said REST model. Okay, get, put, post, and delete. So you use those command methods in order to get access to the web resources that are identifiable through a URI, through a URL. Okay, so and this you're already very familiar with it. We are trying to do something. What are we discussing here? What we are trying to do? We are trying to implement something similar, but not for normal web, but for IoT system. Basically, COAP is this. That is something similar, a REST for IoT. So from a developer point of view, COAP feels very much like HTTP. So those people who are going to use COAP, they won't even know the difference, because it is just like HTTP. Obtaining a value from a sensor is not much different from obtaining a value from a web API. That is, you're getting a particular URL or whatever. Okay, and since HTTP and COAP share REST, so they can integrate. This is what we say interoperable. They can easily be connected using application agnostic cross-protocol proxies. There is a translation that needs to be done from HTTP to COAP and from COAP to HTTP, but this can be done very easily because they are based on the common REST model. So a web client may not even notice that it is just access a sensor resource, not a web server, but actually we are connecting to a sensor and requesting a value from a sensor. You won't even notice it because it's just like an HTTP request. This is what COAP try to do for you. So it is made for billion of nodes, Internet of Things. So we need billions of nodes, and many of which will need to be inexpensive. So COAP is designed to work on microcontrollers that is as low as 10 kilobytes of RAM. Only this low a low amount of memory and low amount of space that we require in order to be able to use COAP on a particular a device. So COAP is designed for minimum resources. I've already told you about it. Yeah, how we are going to see as we proceed how COAP save this energy. So basically, let's compare COAP with HTTP. This is a normal comparison because it seems that COAP tend to replace what HTTP was doing for web. COAP is doing the same thing, okay, for IoT devices, allow IoT devices to request a resource on the web. This is what HTTP allow you to do. Okay, so this is why we are comparing COAP and HTTP. So COAP is a network-oriented protocol using similar features as HTTP, that is REST. Also allow for low overhead. Obviously, it needs to be lightweight and it provides multicast and everything. So HTTP, yeah, this is already, we start seeing some differences here. And you maybe access on those differences and be careful, you know exactly what is the difference between MQTT COAP, between COAP HTTP. This you should be clear about it. So HTTP is based on TCP protocol, because this is why we say TCP IP, using point-to-point communication model that is not suitable for notification push services. In most of the scenarios that we are looking for IoT, it is notification push services. When there is a sensor reading, when we capture a sensor data, you transmit it to some application, to some mobile application. This is called notification. It is push services. When there is data, you push data to your client. It's not that you need to always, the client needs to always send a request for it to get the sensor data. As soon as there's a new reading, you transmit it to your application. This is called push services. So this is how a sensor networks or IoT works. On over the web, you type a URL, then you get. So it is different. So also for constrained devices, HTTP is too complex. So the protocol itself is too complex to be used in IoT. So this is why we have COAP. So unlike HTTP-based protocol, COAP, yeah, this is something very important here to note. COAP operates over UDP. We had this discussion when we were discussing MQTT as well and IoT protocols. So instead of using TCP, which is heavyweight, which is complex, COAP uses UDP. Okay, because at the transport layer we have both the TCP and UDP. So instead of using TCP, in this case, COAP is using a UDP. Okay, which is, we have already seen, it removes all the complexity of error checking and everything, so as it can be lightweight. So UDP, instead of using complex congestion control as in TCP. So this is a major point, that HTTP uses TCP, whereas COAP is using UDP. And COAP is based on REST architecture, just like HTTP, which is in general designed for accessing internet resources. So in order to overcome disadvantage in constrained resource, so COAP need to optimize the length, that is the packet size and everything needs to be optimized, and provide, at the same time, provide reliable communication. How it provides reliable communication, you will see as we proceed. So on one side, we have COAP provides URI. So URI stands for Unified Resource Identifier, is it? Yeah, I think so. So, and REST methods such as get, post, put, delete. So all these are used by COAP. So on the other side, based on lightweight UDP protocol. So this is what is different, and it allows IP multicast as well, which satisfy group communication for IoT. In IoT, you need to send one information to many nodes. So basically, you need to perform multicast, and here we're talking about IP multicast, which is appropriate for IoT. So to compensate for unreliability of UDP, because UDP do not perform those. What is a major characteristic of TCP? These when the data has when there is packet loss here. Let's talk about packet loss. When there is packet loss, there can be retransmission, there is acknowledgement. All these add to the complexity of TCP. Whereas in UDP, you don't have this, so it is unreliable. So COAP defines a retransmission mechanism. So there is another mechanism for retransmission and provide resource discovery mechanism. So, and you will see a figure that will follow. I think I have not yet posted these slides, so I should have posted before the lecture, but anyway, I will post it after the lecture. So yes, you see here on the left-hand side, you have HTTP, which works above TCP IP. Okay, this is normal web. You have program this a lot. On the right hand side, you see this is COAP. Okay, down you see there is 6 low wireless span that do the translation, and then above it you have, instead of TCP, we are using UDP, and then above it we have our message. Instead of HTTP, we have message which can be in terms of request response message. Okay, this is the COAP part. This is what we are going to study here as we proceed in this lecture. Okay, so you see the diagram again here. A diagram, you see, I was telling you at the physical lower data link layer and physical layer, you have 802.15.4. So this is how it is different. This is why IoT sensor system, they are not IP enabled, because we use 802.15.4 and this 802.11 is IP enabled. 802.3 is IP enabled, but 802.15.4 is not IP enabled. So this is why we need to have this 6 low wireless span at the network layer in order to do this translation and everything, IPv6, and you have UDP. And the message that I was telling you for COAP, there is something called COAP Transaction and COAP Methods. We are going to see these two as we proceed. So COAP Transaction provide reliable UDP messaging, okay? Some kind of acknowledgement mechanism as we were talking about. So COAP methods resemble HTTP, all those request response that you do. So this is the COAP methods. So, and it calls, a COAP method calls may invoke multiple COAP transactions. So for one call, there may be multiple transactions. So role of the transaction layer may change during a method request response execution. It can be a response, can be a request, a request. So this can change. So we use URI, that is a Universal Resource Identifier. Okay, I think you know what is a URI. This is just an identifier over the web. Yeah. This is what I was telling you at the start. I was not so comfortable to use the word topics, because in MQTT we say that the subscriber subscribe to topics, the publisher publish to topics. Here we don't use the term topics. Okay, here we use instead URI, because your data, your resource is identified using a URI. Okay, it is identified. That is when you want to connect, you want to get some value, whatever, you need to specify the sensor's URI basically. Oh, excuse me. So as you can get a data for that particular sensor. So the mechanism which is used here, a publisher publishes data to the URI. So again, you have the idea of publish subscribe. So the sensor, basically the publisher will be the sensor. The sensor gives data to a URI, and the subscriber subscribe to a particular URI. Okay, so instead of topics, we are talking about URI in this case. So when new data is published, all subscribers are notified. You see, this is why I was telling you this is push service, notification push. Once a data is available, we push it to all subscribers. Okay, so this is a mechanism we are going to use in COAP. And the problem addressed by COAP, we have already more or less said this. So support for internet REST operation. Okay, resource manipulation as basic concept through use of URI. Yeah, there is the idea of caching also in COAP. When there is a value coming, you can cache the value. So if you have a recent value, you don't need to connect to the sensor again. You just provide a value that you have for that particular a sensor. Okay, we'll see an example of caching as we proceed. Straightforward mapping. Yeah, you need to map. Yeah, you can from COAP, that is my IoT network, I need to transmit to, for example, over the web. So there's a translation that needs to be done from COAP packet to HTTP. This will happen normally. So it enables machine to machine. We have said resource query. It is publish, subscribe, notify. You see, there's a word unit notify here. What is this notify? When there are new values, there is a new value for a particular URI, then all subscribers to this URI are notified. So this is why you have the word notify. Apart from publish, subscribe, you have notify here. And obviously to do this notification, we need to have multicast, because one node sending to many other nodes because we have received a new value from a sensor. Let's continue. Again, this I've already said, COAP uses limited resources, small footprint constraints network, and support sleeping nodes as well. That is, nodes can go to sleep when it is not working. Yeah, have a look at this diagram. All of you have a look at this diagram. This is important. This is the COAP architecture. You see on the right-hand side, here on this side, there is an IoT network using COAP, nodes transmitting to other nodes using COAP, okay? And then there's a proxy here. This proxy will do the translation from COAP packet to HTTP, so as it can be saved on a web server and transmitted to a client that is connected to the web. This here it become IP enabled. Or you can have a node connecting to a server directly using COAP, because we are using REST model here. I put get a delete all this. Okay, so this is then how we can view a COAP network. You can see it better here. Okay, so at the level of the IoT network, so it is a constrained network as mentioned here. Resource manipulation, resource discovery is available, sleeping nodes available, limited memory. All these are characteristics of this side here. There is low latency, okay? And on this side here, there's a mapping here. It is called HTTP mapping from COAP to HTTP. And also at the proxy here, there is caching happening. When a sensor is providing a value, it is cached here. Okay, if ever a client somewhere need this value, okay, so you don't have to connect to the sensor again. If it is a recent value, it is provided directly to the client. This is showing basically the same thing. Okay, so COAP within the stack. So you have the application layer protocol. It uses UDP as a transport protocol. We have already said this. So client server communicate via connectionless datagram. So however, COAP uses confirm and non-confirm messages. Yeah, this we will discuss in detail. What is a confirmable message? What is a non-confirmable message for providing two levels of QoS. So recall in MQTT, there were 3 levels of QoS. Here you have only 2 levels of QoS, confirmable, non-confirmable. We are going to see it with example as we proceed. Okay, so again, the protocol stack for COAP. Down you see it is 15.4, 6 low wireless span. It uses UDP, and this is a part of the COAP mainly here. Okay, COAP messaging in terms of the REST, okay, that allow connection through to the internet in HTTP. Yeah, now it is important. So we are talking about, we say that there are 2 things, COAP message and COAP transaction. If I show you this slide again, it is COAP transaction and COAP methods. Okay, so we are going to see these now. COAP transaction. What is a COAP transaction? What do we have there? So in the message, this is what we are talking about. COAP transaction. In the message, you can have what is called con, non, ACK, or RST. So when it is con, this is a confirmable request. Okay, that the receiving peer sent an acknowledgement or a reset. Okay, so the receiving, upon receiving it, needs to send an acknowledgement. This is what is called confirmable. Non-confirmable do not request any message being sent by the receiving peer. The receiving peer receive what I'm sending. They don't send any acknowledgement. And then ACK itself, this is the acknowledgement message that a con has been received. Yes, I have received a con. Now I'm acknowledging yes. This is an acknowledgement for that particular con. Okay. Whereas RST indicates that a con has been received, but some context is missing in the process. That is, there's some missing information. So transaction on involve peer-to-peer, that is, it is not client server as such. That is Transaction can be peer-to-peer, one node sending to another node. And all transactions are defined by what is called a transaction ID. I will show you an example of a transaction. So, and then the methods that we were talking about earlier, COAP methods, it is the same method that you are familiar with: get, post, put, delete. Get, retrieve information from a particular identifier resource. Post, create a new resource under the requested URI. Everything is identified using URI, not topics. Okay. Put, update the resource identified by an URI. There is a new value, update this particular resource. And delete, that is delete the resource identified by a particular URI. So everything identified through the URI. Okay. So resources are defined by URI. Methods are very similar to HTTP because it get, post, put. Okay. So response codes are a subset of HTTP response code. Okay. And options carry additional information. So you can carry additional information similar to HTTP. You will see, I don't know whether I have it here. No, it will come in another slide. The whole format for a COAP packet. I will show to you. It is on one of the slides. So let's first, since we have seen a transaction, con, non, and we have seen those methods, let's see how message exchange is happening in COAP. Here it is. Message exchange between endpoints. Okay. After you can be peer-to-peer. Here it is written client and server. So messages with 4 bytes header. So let's see the first diagram here, the first exchange. Okay, you have a client sending a con, okay, to a particular server with a message ID. Since it is a con, that the server should respond with an ARC. Okay, yes, I have received this particular con. So reliable exchange through confirmable messages. So how COAP, if you are asked how COAP ensure reliability of data transmission by using confirmable messages. This is what you should explain, and there is an acknowledgement and everything. Okay. So simple stop and wait retransmission with exponential. So now what happened if I've sent a con, but I don't receive an acknowledgement? So here, most probably we'll need to send the con again, but you will need to stop and wait. Okay, retransmission with exponential back off. That is, if you continue to not receive, so you wait for longer. Okay, so this is a technique we use in networking in general. So unreliable exchange through non-confirmable message. So this is unreliable. That is, you send whether the receiver has received it, has not received it. You don't care. Okay, there is duplicate detection for packets that are being received 2 times, 3 times through the message ID. And so basically, the request response is piggyback on COAP messages. Okay, this whatever required for request response, it is added to COAP messages. This is an example of a COAP request response happening between a client and a server. You notice here this part here. Can you see my cursor when I'm moving my cursor? I don't know whether this is available on Zoom. Anyone?
Yes. Yes, you can see it.
You can see the cursor. I'm just confirming. Okay, so you see here con 0xBC90. So this is a 0x, and I think this is the message ID, but this is a con message. Okay, this is a transaction. Con is a transaction. This is what we call a COAP transaction. Then we have said the request response is piggyback. We said somewhere the request response piggyback on COAP message. This is what is happening here. That is, we have a con, and inside it we have get temperature. This is our normal request response. Okay, get temperature, and there is a particular token for this message. Okay, and we're sending to a server, and the server is responding with an acknowledgement here, and you see some content also here, 22.5. We have sent get temperature, and the server is responding with an acknowledgement through and using a particular content, 22.5 for that particular token. Okay, another example on the left hand side here. Okay, this is another ID, get temperature. Okay, in this case, the server is responding not found, not available. There is, even if the data is not available, you see there is an acknowledgement saying that yes, the data is not available. So the acknowledgement packet will do this this job. Yeah, you can have also separate response. Okay, so what we have here, you have a con that you are sending to get temperature to the server. There's an acknowledgement, but there's no data coming. You notice in the acknowledgement, there's no data coming. We wait after some time. When there is data from the server, then you see it is responding to a con that was there before, well before. So it is responding to this con that was sent well before. So, and it is sending the contents 22.5. Maybe after some time, the value that is a particular sensor data has come. So then we are sending the message, and you see here, since we are sending a con, so you recall we said that we can change role. So a server sending a con, a client sending a con. So the request response, we can change role. Like in this case here, it is a server that is sending a con, okay, and it is a client that is returning an acknowledgement. Normally in these cases, the client sending con and the server sending acknowledgement, the client sending con, server sending acknowledgement. Whereas here, first time it is client sending con and server sending acknowledgement, but after some time passes, it is returned here. The server responds with some value and the client responds with an acknowledgement. This is COAP, how COAP works. What is happening here? Yeah, this is just a non-conformable request. Okay, non-conformable request that you don't need to acknowledge or whatever. So we use, I've already explained, we use the stop and wait approach. Yeah, if ever I sent a, what is happening here? We sent a particular con. Yeah, you notice here what has happened in this diagram here. A COAP client is sending a con. Somewhere the packet is lost. There's a cross here. Somewhere the packet is lost. So COAP is waiting, since it is a con, it was expecting to get an acknowledgement, but after some time, you see ... here, after some time, we don't get an acknowledgement. So we conclude that most probably the packet has been lost. So we reinitiate our con 0x, this is the ID, get humidity. I send it again to the server. Now I get an acknowledgement. So I'm happy. So I don't retransmit. So you need to wait for some time. So it says repeat a request after a timeout in case acknowledgement is not coming back. For a particular con that I have transmitted, I have not received an acknowledgement. I wait for some timeout before retransmitting the con. So as I get an acknowledgement. Yeah, normally how we decide how much to wait, there is a timeout factor that we use. So timeout set, so it is a random value between 2 times, acknowledgement timeout and acknowledgement a random factor, for example, 2 to 3 seconds. Okay, timeout can be anything between 2 to 3 seconds. So when the timeout expires, so the transmission counter is less than max retransmit. Okay, so you have already waited for the time, so you can retransmit. Okay, and each time there's a retransmission, you increase the counter. Okay, you need to, second time we wait for more, third time we wait for even more. Okay, this is what's called a exponential increase. So a acknowledged is received, so a RST is received, so the procedure is repeated until we have an acknowledgement which has been received, or until the transmission counter exceeds max to retransmit. So that is, here we have already exceeded the maximum retransmit time, and the total attempt duration exceeded. Okay, there is a maximum duration that we can wait. In this case, you see here 93 seconds, after which we will drop, we will not retransmit. Let's see these examples. So there are different examples here. One is synchronous on the left-hand side here, sending, receiving seamlessly, that is synchronously. Okay, here sending and receiving asynchronously. And here what is called often a transaction. Okay, sending 50, receiving ID 50. sending 51, whereas the server is sending this time, and it is a client which is responding. Okay, so these are the different kind of mode that your COAP message can be exchanged. This is what I was telling you, the packet for each COAP. You see there are different control, like message ID we have seen, a particular code associated, the token we have seen, and here you have different options. And here we have the payload. So the structure basically for a COAP message, you have the message ID, you have the message token, okay, set of messages belonging together. So if there are similar messages, so they are grouped using their message token. They have the same message token. Okay, so you have message option, parameters, and handling mechanism. Message code, the purpose of the message. Is it a request, response? What kind of message it is? This is the message code that it needs to be a pinpoint there. It needs to be stated in the message code. And message type, confirmable, non-confirmable, non, ACK. So we need to state this. So basically, I was telling you the code. Okay, the method get, put, whatever message ID is a transaction ID, and numbered options. So specify URI or whatever, and then the payload. This is for the transaction. Yeah. Now that you know how messages are exchanged in COAP, there is a mechanism I've told you earlier at the start of this lecture that we can have caching happening, caching of COAP messages. So COAP support the caching of responses in order to efficiently fulfill requests. That is, a sensor has sent a value, a sensor value to a proxy, and a client is requesting that particular value. Okay, so if you already have a value for that particular sensor and the value is quite recent, so you don't need to connect to the sensor again to request a new value. Okay, you can just send the value that you already have at the proxy. Caching is enabled using freshness. Freshness is how recent the sensor value is. Okay, if it is recent, you don't need to connect to the sensor to get the value. You transmit the value that you have. But if it is not recent, then we can't transmit this information. We need to connect to the sensor, request a new value. So proxying is useful in constrained environment. Why proxying, even caching, or we're talking about caching, is important. It is useful because to limit network traffic, instead of communicating again to the sensors, you already have values stored, so you transmit directly. Okay, improve performance obviously, because we're talking about constrained network, so we cannot waste our resources. Okay, so, and to access resources of sleeping devices. So when using a proxy, URI of resources included in the request, and destination IP is set to the address of the proxy. So the request goes to the proxy. If there's a value there, it will return to you the value. Don't connect to the sensor. Here it is. You will see a complete example. Let's check. Let's follow the example together with me. So what is happening here? There is an HTTP client on the right hand side. You see the HTTP client sent a request to the proxy. Request for what? HTTP get light. This side is not COAP. This side is HTTP. It is internet. So a client requesting to a proxy, to a COAP proxy, give me light, get light. This is HTTP, and then the proxy. Excuse me, please. Then the proxy transmit the request, obviously using a con, because this side is COAP. So the con transaction, con, inside it you have your request response, that is get, in this case, get light. And then this is sent to a COAP server. And then the COAP server sent an ACK together with the content to the proxy. And then the data is transmitted to the HTTP client. Up to here, it is normal. Up to here, it is just a request response happening between an HTTP client and a COAP server. But see what happened. The value that was sent by the COAP server has been saved at the proxy. You see a cache line, the light that we have got here, it is cached at the proxy. Next time you see here, there's a request coming for get light. Okay. the proxy check whether we have a fresh cache, whether we have some data for that request, we have some data that is still valid, okay, that has not paused its freshness. And you see maximum age, it says 30 seconds. Okay, you see here when it was written, maximum age is 30 seconds. That is, if we have already gone above 30 seconds, then we need new value. Otherwise, we can provide the same value that we have at the cache. And in this case, there is a client making a request. Okay, so we already have it, the value that the client wants, we already have it in our cache, so we respond directly to that client. Yeah, now there is another concept. So we have seen the concept of proxying and caching, which is useful, as you can see here. There is another concept called observation. Okay, I've mentioned it earlier at the start of this lecture, but now we are going to see example of it. So we say that REST paradigm is often pull. Pull means what? It's only when you, for example, to get a particular URL, you need to type which URL, and when you make a request to the server, then the URL come to you, okay, as a client in your browser. This is called pull, because I am pulling, I am making a request, then I pull it directly from the server. This is called pull. Whereas in IoT, what we have said at the start of this lecture, IoT uses push. Okay, that is a value. We have just got a value for a sensor. I push it to all those subscribers, all those clients that want to have this value. So you see here, REST normally is pull, whereas in IoT we use push mainly. So that is, data is obtained by issuing an explicit request. You need to make a request, type a particular URL, then you get data. And now in IoT we don't do it this way. In IoT, information data in WSN stands for wireless sensor network, is often periodic. Periodic means I want to have the sensor value every 5 minutes. Every 5 minutes, give me a value. 5 minutes, give me another value. 5 minutes. So this is called periodic. Or triggered. As soon as there's a new value, give me the value that you have got. This is called triggered. Both here we are talking about push. It is not a pull. So how to implement this? Because here we were still talking about, here in this scenario, we were still talking about request response. We were still talking about, how do we call it? That is you set a request, and it's only when you send the request that you will get the response. Okay, so here we're talking about something different. I want that as soon as we have a value, let all subscribers have this value. So how to implement this idea, this a push, a publish subscribe on this? So we are going to see how we do it. We use what is called observation on COAP resources. You show interest in a particular URI, and then as soon as there is a value for that particular URI, you will be informed about it. Here it is. This is an example. You notice in the first one here, I say get temperature, this particular topic, and then observe register. I register my interest in this get temperature. As soon as there's a temperature, let me have this temperature. And you see a notification of the current state, 22.9 degrees Celsius. Okay, observe. Okay, it is observed, 22.9 degrees Celsius. And then as soon as there's a change, 22.8, you see here there has been a change in the temperature, 22.8, so notification upon a state change. Then the client get this new value. There's another change, the client get this. So each time I'm observing that particular get temperature. Each time there's a change with temperature, let me have this value. So this is called observation, and this is how COAP implement push notification. This is a push basically. As soon as there's a change there, it is being pushed to the client. It is not pull. It's not that I'm making a request each time. Okay, what is happening? Automatically, the new value is coming to me because I have already registered my interest to observe that particular sensor. So this is how COAP is implementing push push notification. So these details you should be aware very well. And basically, I am quite sure if a student have not followed this lecture, they won't be able to answer questions related to what I am discussing, even if they go through the slides and everything. Yeah, let me now, we have already now discussed about what is COAP, how COAP works, how messages are exchanged, what are the concepts of caching, what is observation. So we have already seen all these with respect to COAP. Just like MQTT, we had MQTT implementation in Eclipse PAHO, you recall this, okay? For COAP also we have COAP implementation. There are some operating system that is based, that uses COAP only to communicate, operating system for constraint node. There's an operating system, I know that you have not used it, but just for your information, just like TinyOS, there's an operating system that is called Contiki. Okay, quite popular in the domain of sensor system IoT. Okay, when you have low power, low cost microcontrollers, you want to have an OS installed on those microcontrollers. So many of those install normally Contiki, what is called the Contiki operating system. Why am I mentioning this here? Because Contiki uses COAP. It implements COAP. Yeah, another implementation of COAP. So tomorrow, if you want to program, just like for MQTT, there was Eclipse PAHO, and we were able to have MQTT implementation there. We have something called Californium. Okay, it's a Java-based implementation of COAP and available in Eclipse. You see, Eclipse is quite a big IDE. You see, it make provision even for MQTT. There's provision even for COAP. If you want to implement COAP, you can do it in Eclipse. Okay, you see the link here, www.eclipse.org/Californium. It is available. So Californium is a powerful COAP framework targeting backend services communicating with smaller Internet of Things devices. Stronger Internet of Things devices may use Californium also. It provides a convenient API for RESTful web services for you to be able to connect to the to HTTP to internet. Okay, using from your sensor device to the internet using Californium. Okay, that is available in Eclipse. I'm giving sample codes if I'm not mistaken. As we proceed, you will see it. So there is another one called iCOAP. This is for Objective-C. If you are programming, because the previous one was Java. This is if you're doing it in Java, then Californium is an interesting choice. But if in Objective-C, then there's something called iCOAP. For Android, if you're doing a mobile application, the easiest one and the best one is still Californium. Okay, can be used on an Android device. Okay, you have something called a COAP. Okay. COAP, it's in your browser in Firefox, an extension of Firefox to enable access to your COAP resources via the browser. So it is available even in Firefox. I'm telling you different implementations of COAP. So to get started with COAP, if you want to implement COAP, obviously in this case we are using Californium available in Eclipse. So Java COAP Californium, there are different libraries as well. Okay, after you TinyOS and Contiki operating system that has COAP support, and Firefox has this COAP as after you. In Wireshark also you have a COAP, a plugin. We are going to see. You can have Californium under this link, and co-library and example project also are available in GitHub. So basically, for you to implement a COAP application using an application using COAP, so if you're using Californium, this is the link where you have all the necessary libraries, org.eclipse.californium.co. So there are those classes that are available: COAP server, COAP resource, COAP exchange. Okay. Normally, if you have those classes, you will be able to implement the server side very easily. For you to be able to publish at the sensor side, excuse me, to publish a particular data for a sensor. These are clauses that are already available in eclipse.californium.co. Okay, so we implement custom resources by extending the COAP resource clause and add resources to a server, and then you just start the server, so the service is available, so client can make requests from there. I'll shoot you. I guess I have sample code. Here it is. Let's check what are we doing. So this is what we import, eclipse.californium.co, and then obviously COAP. And we are extending the COAP resource clause here. My resource, this is a clause that I'm writing, which extends COAP resource. So it is a resource. And here I'm implementing my get and post. Okay, get COAP exchange hello world, for example. Okay, and post a COAP, whatever you're receiving for for post. So this is how I've implemented get and post in Californium here. Okay, that is available in Eclipse. Let me check exchange.response created. This is just a display. Yeah, here it is. This is what I was looking for. Where are we starting the server? So in your main here, you see here COAP server. Server is called to new COAP server, and then you just add it to server.add this to my resource clause here. And what are we passing? We are passing hello to that server. And we just say server.start. Server.start. So now this service is available. This one. Here it is. This get and post is available because we have created it and we have associated with our my resource and add, and we have started the server. Now you have your COAP server is ready. Obviously, this is something very simple, just to say hello world. So this is the server side. This is how you are going to implement the server side. Okay, the server has been created. Now on the client side, you want to access a particular resource, and recall we use URI. Okay, so on the client side, these are the important libraries. Again, we are discussing about Californium here that is available in Eclipse. So the classes, COAP client, COAP handler, COAP response, and COAP observation, that is observe relation. So instantiate COAP client. So we need to create, just like previously, we were having COAP server here, COAP server. Here we have COAP client. Okay, so we need to instantiate our COAP client. Use offered method. These methods are already available. Get, push, pass, delete, observe. These are available. Optionally define a COAP handler for asynchronous. If you are implementing an asynchronous application, then you need to use the COAP handler for asynchronous request and observe. If it is request response, we use above, get, push, that is put, get. Okay. If you're implementing an asynchronous, that is you show interest, when data become available, then you will be informed. So you need to use COAP handler. Let me see in the example what I have. So you see I'm creating a COAP client. Okay, COAP client 1 is called to new COAP client from this URI. Okay, and get response, booking a call, and save the response here. And here I'm creating another client again, text whatever, and I'm getting for client 2 dot put a particular payload test here. Okay, and then client dot, you see here is a transaction we are talking of with client 2. Here it is, client 2. Client 2 dot use non-message. This sending a non-message, a delete, a use con. Here it is, con message, a con message which is being transmitted using COAP. This is my COAP client, and here I'm just instantiating the client in this case, onload COAP response, getting the response from that particular request that we are making. Okay, so this is mainly for asynchronous. Okay, because you see here for asynchronous we need to use the COAP handler. Whereas here it was COAP client directly. COAP client. This is how we exchange our message. Whereas here it is for the asynchronous. It is the COAP handler that we are using. And here is the observation. Okay, I create your COAP observe a relation. Okay, and you show interest for a particular information. Okay, so this is it. I've just browsed you through the implementation. It's only when you are going to implement that, really, if you're using it, then these codes will become useful. Okay. Otherwise, what I will request you to do, or we have completed our COAP discussion. I will request you to at least analyze an open source implementation of COAP. Okay. You can use a Californium itself. See a complete example of Californium. And very important, compare and contrast the following protocol. Since we have already discussed about MQTT and we have already discussed about COAP, so compare, contrast these two and compare it in terms of resource requirements, reliability of connection, QoS, interoperability. So these are things, and how message exchange, what are the different facilities that you have in both those protocols. This will be very useful to you to answer questions that you may have in the future. And then there is a few links here you can about COAP implementation and everything. You can check. There is even video and everything that you can check. Okay, so this is it for COAP. We have reached the end for our discussion on COAP here. Any question? Let me go back to. Let me check if is Ramjoni around?
Yes.
Okay. Yeah. Any question from the class? So main point here is COAP. You need to differentiate it with MQTT. How COAP works. With respect to implementation, even implementation codes, you may be getting, if ever you are getting a question in your test or exam, you may be given sample codes and you have to explain things like this. But it is very unlikely that I will, for example, in the exam, request you to implement a complete client, a complete server, even a publisher or a subscriber for MQTT complete. But there may be questions with respect to the code. I'm not saying that you won't have questions with respect to the code, but it is very unlikely that I will request you to implement a whole application or whatever. But you need to know to know those codes, what they are doing. Any question that you may be having? We will need to plan a class test, not now, but in the coming weeks. I still need to give you your marks. Hopefully, if we return to university, I will return to you your scripts for semester 1 test script. The different assignments, I think most of it I have marked. Those that have marked, I've already sent you feedback through Google Classroom itself. Otherwise, there are a few also that I know you have submitted where I need to still mark it. And then you have, obviously, for second semester, you have your mini project that is ongoing. Most probably not this week. This Thursday, there is I have an important meeting. I will plan a meeting with you online itself. On specifically on mini project, where different groups come and explain to me what you're doing. If ever there are any issues you want to discuss with me, we can discuss it. Otherwise, I'm giving you lab work offline. You have noticed at the end of each lecture, there is some lab work which is being given for you to practice, for you to work on. Yes, any question from anyone? If not, let me stop sharing and stop recording.